Today's video is sponsored by Native Sons Goods, makers of premium quality guitar, bag, and camera straps, handmade in Albuquerque, New Mexico. Check out their website to order your own custom creation and play in style. And remember, when you support my sponsors, you support this channel, and I sure appreciate it.
Oh, that's hot. That's hot.
That's hot. That's hot.
Hello, boys and girls. Brad the Guitologist here. Welcome to part 4 of this epic wrestling match between yours truly and a demonically possessed Mesa-Boogie DC3 guitar amp. In previous installments of this series, we sought to solve the issue of a red plating output tube pair by replacing tubes, reflowing solder on the output tube board, rebiasing to drop the criminally hot output tube plate dissipation by about half, rebuilding the entire bias circuit, replacing coupling caps to the output stage. We also ended up replacing the output board with discrete components, and when we still found red plating tubes, we tested the output transformer using a novel test method and ordered a replacement. That pretty much gets us caught up, so check out what ends up happening with this amp. I think you're gonna be amused. Okay, here's the old transformer out on the desk. I had replaced it with a different transformer thinking that this was going to work. This is an off-the-shelf transformer for a Fender. Problem is the impedance, the primary impedance is off just enough so that this thing is not going to work. And that's my bad. I pretty much ordered the wrong thing thinking I could make it work. I was going to try to redesign the bias circuit just to accommodate this. That was going to prevent me from having to order a Mesa part, and plus this Mesa part is just small. You know, I'll spare you all the details, but the idea here was that I could beef up the output transformer at the same time that I replaced it in an effort to improve the amp overall. But that's that plan A has kind of gone out the window. So what I'm going to do is I'm going to backtrack. I'm going to look at this, examine it, and see what the turns ratio is. And in order to do that, first thing we're going to do, we're going to plug it into the Variac. You can see the plug that's plugged in. So I'm going into the secondary. I'm going to put about probably 10 volts into the secondary, and we'll see what comes out of the primary. You could try to put 1 volt as well, but it's just as long as it's something that's easily divisible by 10, it just makes it a little easier. All right, we'll just dial it up and get as close to 10 as we can. And if you do this, you want to be very careful because there will be hundreds of volts on the secondary. It's stepping up the voltage considerably. Okay, 9.9 volts is going to be pretty darn close. So let's take our wires, our leads here. We'll, which one is which? Okay, we need to measure. We'll measure across the entire primary. 270 volts. So our turns ratio is 27 to 1. So what we can do now is we can calculate what the primary impedance is going to be based on what the secondary impedances are. If we assume we're using our 8 ohm tap, which on this side we measured our 8 ohm tap. We could have measured our 4 ohm tap as well and done the calculations that way, and it would have we would have arrived at the same conclusions. It just would have been with the 4 ohm tap. Okay, so we want to do 27. That's our 27 to 1 ratio. Okay, so we do 27. We'll square that, so that gives us 729, and then we want to multiply that by 8, which is our 8 ohms. And that right there is going to be our primary impedance. Anything from probably 5700 to 6 is going to be about right. The problem is, if you go on websites and you start looking for off-the-shelf transformers that you can replace this with, finding something that has the primary impedance that you need, but also has the secondary taps that you need for 8 and 4 ohms is almost impossible. The thing is, these secondary impedances are for 4 and 8 ohms, whereas, you know, if you try to find something that was designed for like a Vox or an old Marshall, for instance, which are the common amplifiers that you find with this many EL84 output tubes, you know, like the JTM30, for instance, you'll find or the Vox AC30. You'll find amplifiers that have 8 ohms and 16 ohm taps, or just, you know, one or the other even. So you won't find something that has like an 8 and a 4 ohm tap in this sort of configuration. It's just, it's almost non-existent. I didn't realize how difficult that was going to be until I started shopping around for one, but apparently finding an off-the-shelf transformer for this is quite impossible. So what I've done, I found a used transformer on Reverb that is this exact transformer. So we're going to get a replacement Mesa transformer, and we'll take this one out of here that I put in. And unfortunately, my experiment to try to see if this transformer for a like a Fender Hot Rod Deluxe, which normally, you know, again has 2 6L6 tubes, was going to work, and it does not. What happens when you fire this amp up? It just begins squealing very loudly. If you were ever curious as to what an amp would do if you had mismatched impedance like that, that's what it's doing. And my attempts to rein it in by changing the resistors in the bias circuit have not borne fruit. So, and this thing, the saga just continues. And I mean, frankly, I'm just ready for this thing to be off my bench so that I can get some other stuff done. All right, guys, we are back with this Mesa-Boogie, hopefully for the last time. I have yanked the transformer that I bought for this thing back out of it. And this transformer was intended for a Fender Hot Rod Deluxe or Blues Deluxe. This is like a replacement for one of those that you can get on Antique Electronic Supply. Here is why I was going to buy that transformer and put it in instead of going to Boogie, because it should have been in the same region on primary impedance that a 4 EL84 amplifier would have been. It wouldn't have been exact, but it should have been close enough that we could have popped it in and rebiased the amplifier, basically doing a minimal amount of redesign on the output, and it should have worked. The problem is it did not. All it did was screech at me, and the reason for that is the impedance was further off than I thought, and I should have actually, had I done my due diligence, I should have measured that first, and that was my fault. You have to sue me on that one, but I'm going to eat this transformer. I'll eventually use it in something else. It's a universal enough transformer. You know, it'll handle 4 and 8 ohm outputs with, you know, a couple of 6L6s or EL 34s or something like that. I can always build something with this or replace something in the future that needs this, so it's not a complete loss, but I was trying to save him a little bit of money over what a Mesa transformer would have been. So what I have done, I went on Reverb.com instead, and I got a Mesa-Boogie replacement that was a used replacement. And I think this one is going to do the trick as long as it works. I'm hoping this will be the last I'll have to see of this thing ever. No offense to the guy who brought me this, but you know, this has been one of the, this has probably been the biggest pain in my ass all year as far as amps go. But again, not his fault. A couple of the issues were, you know, kind of my fault. But at the same time, you know, a lot of it was Mesa's fault because of the way they just designed this amp, particularly on the output. So anyway, I have the new the new output transformer installed, and everything's pretty much ready to go. I'm going to fire it up on the Variac, hook it up to a load, and see what we get. Okay, so here we go. We're about to fire this thing up for the first time with the new output transformer. So let's see how this goes. Let's see where we get to. One of these is monitoring the bias on one side. One of them is monitoring the bias on the other side. I don't know how accurate these are. I would trust the Fluke probably a little bit over this triplet, but at the same time I have no reason to distrust the triplet. But it is looking like our bias is slightly off from one side to the other, but that could just be because of the slight difference in impedance from one side of the transformer to the other. But that's kind of a worrying sign because we do have a significant difference in negative voltage here. I'm going to leave it here for a little bit, see how it settles. I'm going to pay particular attention to this side because this is the side that kept running away on us before. If that changes, And if it stops running away, then we know we got the right diagnosis. The power consumption for the amplifier is about where we want it to be before it started running away. Something tells me we're going to be okay with this, that this is not going to run away. I am going to do some measurements here. Actually, as a matter of fact, I do want to go ahead and... Okay, so yeah, these are off. This one's 14 over here on this side, according to the fluke. And it's 14.3 on this side, according to the fluke. So there's just a difference in measurement here. That's actually fairly significant. The battery could be running down on this triplet, or it could just need calibration. It could also be that my fluke needs calibration. And essentially at this point, I'm just going to watch for one of these, you know, starting to go drastically awry from this figure. So if they start moving on me, then I know we've got problems. Well, our bias on this side is starting to collapse on us again, it looks like. And our voltage is starting to go up and up and up, or our wattage rather, our consumption. And here anytime now we should probably start to see these goddamn tubes start to red plate again. You have got to be kidding me. You really got to be kidding me. What else could it be? The phase inverter? I mean, it really shouldn't matter. You know what though? I know this is collapsing on me. I've got this 11.4. It's just going down, 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 and that's going up, 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 and it's going to just go up, up, and up more and more rapidly. Okay, so I've pulled the phase inverter tube out of the amplifier, and this is a Mesa tube. I'm just wondering if it's possible that it could have been this phase inverter tube all along. This is the one tube that I did not replace, pretty much. I think I replaced all the preamp tubes except for the phase inverter tube. Right now it's on with no phase inverter tube. It's not doing anything. It's not running away over here. Okay, I'm going to get a new phase inverter tube, pop one of those in here, and see what happens. If this ends up being a fucking phase inverter tube, I'm going to puke. I really am. I'm going to puke. Because when I put up that last video, all the tests that I knew to do came up pointing to the output transformer. Some viewers said, you know, check that there's not some oscillation going on. It did not make much sense to me in the context that I was looking at it, because the output transformer looked like it was going to be bad. Now, a couple of you guys asked me why was it popping whenever I would do that test, even on the Mesa-Boogie transformer. Okay, so the old Mesa-Boogie transformer, it would make the little pop when I would do the test, but the light would not light, if you'll recall. Well, the reason for that is I was using my bench power supply, and the bench power supply is connected to the same outlet as my mixer for my audio, which I assumed is what was causing that to happen. So it's quite possible that there was voltage, that the windings rather were fine in this transformer, but that the light was not lighting because there was not quite enough voltage to light it. So it could be that because the impedance was way different, that it just there wasn't enough there to quite flash the light, but the windings were still okay. So I think that test could be flawed. There is an article that you can read, I think it's Premier Guitar, that talks about that test. It's called the Super Secret Transformer Tester or something like that. My friend is the one who turned me on to it and said I might try it out in this instance. It could be that test is flawed, that it doesn't account for certain primary impedances, perhaps, in some transformers that won't let the light flash. So I don't know. At any rate, we're going to test this out. I've got the voltage is back down almost to zero, so we're going to flip this thing back on here in just a second. I've got a new phase inverter tube in there, and we're going to see how this works out. I can also test this tube and see if it's the tube. I've got a tube tester, obviously. I can put it in. But the thing is, you know, tube testers, they're kind of unreliable for finding stuff like that. For finding out tubes that are microphonic. It's not going to tell you much about microphonics or about a tube that will create an oscillation. So, and I just don't see it as being an oscillation problem. I mean, don't ask me why. It just, my instinct is telling me that's not it. I'm actually hoping it is it. I'm hoping my instinct is wrong on this, but something is telling me it's not, and I think it's going to end up being this board that's just been cooked for 20 years. Yeah, but see, this is kind of a worrying sign. 0.4, 3, 2, 1, 0. See, it's just falling steadily. I kind of want to hem in the problem. So the way I'm going to do that is the coupling caps that come before the output. So these coupling caps right here, these are the ones coming off the phase inverter that feed the output tubes. I want to lift one of the legs on these coupling caps, and what that's going to do, that's going to cut off any signal that's coming in off of the phase inverter. These tubes should still have bias, because the bias comes in after that, and I want to see if it stabilizes. If it does stabilize with these lifted, we know probably there's some sort of problem in the phase inverter, or before that, that's causing some kind of oscillation or something on that one side. Let's go ahead and do that, and we'll try to isolate this down. And I think if we still see the issue at that point, if it's still doing the same thing, then we know, because I've replaced all the other components in this bias supply, so we know there is an issue with this actual board material. So that's going to get interesting, and what we might have to do at that point is build all this stuff off of the board. The thing on this channel, I have not yet had an amplifier beat me. I've had a couple of cases, one or two, where I sort of sent the amplifier back and said, hey, this is going to cost you more than I'm willing to get into. It's going to cost me a lot in time and headaches, and I'm not taking this in. So that's happened before, but I've not had an instance where an amplifier has beat me and I was not able to at least fix it. So, and I don't want this to be the first, but I do probably want this to be the last Mesa-Boogie I ever take in, to be quite honest. Boy, that sure doesn't seem like. There we go. Okay, so we'll be watching this voltage right here. This is the bias voltage on this pair of tubes over here, so we'll watch it. And I expect to see somewhere around 14.5 or 14.2 it should settle down to. Okay, it's beginning to dive a little bit, pretty steadily now. You can see it. It doesn't look alarming yet, but it's starting to dive on us. This one's still at 14.8. And this one has dived down to 14.3. And also, if we look over here, we can kind of monitor this power level right here. This is the primary of the power transformer, basically, is what we're measuring right there. And you can see that it's starting to creep up as well. This is what I've done. I've lifted the legs on these 047 capacitors. These are the coupling capacitors coming off of the phase inverter. So nothing's coming through, so there's no possibility of any oscillation or anything like that happening. A lot of you guys were suggesting, hey, I should hook this up to the oscilloscope and check for oscillations. I did not suspect that to be the case, because why would it be happening on one side? Of course, you could have one side of a tube, that's bad. That's possible, but a little bit less likely. It didn't make a whole lot of sense, especially since these get their bias from the same source as well. So if one side was going into oscillation, I would have expected that to happen on the other side as well, and that just wasn't happening. So with these lifted, we're getting runaway. We're really running away, and it's doing it rapidly now. And we really have crept up over here. See the power level right there and the amps. So that issue remains. So that was a very valuable test, and what that has told us, a couple valuable tests actually in there. And if I had done this test before I replaced that output transformer, I would have said, okay, oh, it's the output transformer. but we've already replaced the output transformer. So that this test is telling me that we have an issue on this board, most likely. Now, I do want to go ahead though and do one more test. I want to swap the leads on the output transformer. That's going to narrow it down even further. If this side still red plates even after swapping those primary leads, then we know that we have a bad trace on this board. This board is actually becoming conductive. However, if it swaps, then we know this output transformer that we got has the exact same problem as our old output transformer, and therefore we need to send this output transformer back to the person we got it from, and then we need to just probably go to Mesa perhaps, or we can go to maybe Mercury Magnetics, or we can go to Classic Tone or something like that to try to get a output transformer with this 5700 primary impedance, which seems to be rather weird. The thing about Mesas also is that they have designed this output apparently deliberately so that you have to use their proprietary sort of output transformers if you want a drop-in replacement. Otherwise, you're going to have to do so much redesigning. It's not going to really be economical if you try to use something off the shelf. I'll monitor the bias on the same side that we've had the problem on, and then I'll also monitor the overall. If the problem was in the output transformer, it should the problem should have moved over to here. But right now it's looking like, because it's below 14.8, which is what the other side stabilized at, then that's telling me that the problem is on this board already, most likely. Alright, probably less than a minute later, here's what we're faced with. We have bias that's creeping downwards, just creeping, ever downwards. And it'll just go and go like this until you'll turn around and then, you know, your tubes will be red plating. But you can imagine being at a show and having something like this happen. You know, I mean, it would not be fun times, especially if you didn't bring a backup amplifier. I hope that the show that he tried to use this on, he had a backup. Something tells me he probably didn't, because I was fairly confident that the problem had gone at the time that I gave it back to him. But now it is predictably doing it every single time you fire this thing up. So it's not even intermittent anymore. This is a new one on me for Mesa-Boogie. I know people have experienced this, and I've had a couple of experiences where I think a Marshall amplifier may have had a slightly conductive board, and I've had to do something to sort of compensate for that in the past. I did not do the drastic thing that some people have to do, which is drill out around some of the pins. But on this one, this is going to be interesting, because I'm going to have to actually move. There's some components I'm going to have to move here, and I'm not sure which ones. Somewhere on one of these two traces on the board, because this will be basically one continuous trace right here, and then this will be a trace. So somewhere on one of those two traces we have a problem. Houston, we have some kind of leakage to ground, or leakage to another trace. Something is going on to cause this to happen. So I think what I'm going to do first, I'm going to fly these components up off the board, and we'll just kind of probably do it here on the desk with leads, just to see if we can't stabilize the bias coming in. And if we can stabilize the bias by flying these components up off the board onto the desk, then we know what we're going to have to do. We're going to have to fly them permanently onto some terminals. So let's try the desk thing first. Okay, so this 330K resistor right here is just pointing straight up. It was into here. So I've lifted this leg here, and it's straight up in the air. This lead here has to tie onto that. So in order to do that, I have to cut the silicone that I put on these. Okay, so now this can fly freely up off the board, and we want to create a tie point right up here in the air, like so. So there's that. I need to take this gray wire right here off, and I've got to replace it with a longer wire that'll reach. Okay, It looks like it might be creeping down some. 14.3, huh? What does the other side look like? 14.7 still.
The birds! He rises!
You gotta be joking me. It's running away. Why is it running away? Why would it be running away? Everything has been eliminated. If you see where the 330K resistor is touching the board down there, you see those two 330Ks, they're going to one common point and then to that resistor right there. So that common trace, why, I mean, the only things that's separating these two, shit, I don't get it. I don't, what is going on with it? I mean, clearly it's running away again. So let's kill it. But do you see what I'm saying? It's like if it was, so it's not the trace we suspected it might be. What are the other options? The problem with thinking that it's, what I'm trying to get at is the problem with thinking that it's on this side of these 330Ks in the bias supply is that these are both common, and if you're getting a problem over on this side, then it will affect this one also. It will affect this line, so it will throw the bias of the other side off, at the same time it's throwing this side off. So it can't be that. It's impossible for it to be that. So what's left? There's nothing left. There's literally nothing left.
And God had prepared a great fish to swallow up Jonah.
Bear with me on this. I've rebuilt, just to recap, everything I've done in this amp.
Jonah thinks that a ship made by men will carry him into countries where God does not reign.
I rebuilt the entire output section, okay? So all of these tube sockets have been replaced. The tubes themselves were replaced the last time I had it. All of these resistors on the output that were on the output board have been replaced. All of the resistors for the screens have been replaced. The entire bias supply has been rebuilt. So that includes this resistor, this resistor, this resistor, the bias capacitor and the bias diode, and also this resistor over here on this side that's biasing the phase inverter. All of those have been replaced. Now a little bit ago you saw me do this. You saw me lift both of these coupling capacitors. So I lifted legs on both the coupling capacitors, and the problem still happened only on one side. Okay, so what does that tell you? That tells you that the problem cannot be on the other side of the coupling capacitors. It cannot be coming from the phase inverter. It can't be an oscillation coming from the phase inverter. Okay, so that's out. That's ruled out completely. The test that we did when we lifted those rules that out. It cannot be the output transformer, because the test that we did with the output transformer, swapping the leads, it stayed with the sockets, not with the output transformer. So it's not the output transformer. So in spite of our previous tests in our previous video, it turns out that test was unreliable, and it's not the output transformer. So again, what's left? What the hell is left? What's left?
I fear the Lord, cries Jonah, the God of heaven, who hath made the sea and the dry land.
I mean, what are the odds that I change something over here and a component's bad on the same side that, we previously had the exact same problem of runaway bias? I mean, it's just, that doesn't make any damn sense. That's at the very bottom of the possibilities list, that something that I replaced, is also bad, and bad in the same way. It can't be this and it can't be this resistor, because those were replaced late in the game and it was already having the problem. So it's not any of that. There's literally nothing left.
The white whale tasks me. He heaps me. Yet he is but a mask. 'Tis the thing behind the mask I chiefly hate.
I don't know how to say this, but this thing is the impossible to fix amplifier. It really is. I don't get how this could even be happening. And the thing is, you know, I replaced that 330K resistor. So it's not that resistor. And it was failing already on this same side. So whatever it is, I clearly haven't found the problem and resolved it. But there is nothing else. There's nothing else. There's literally nothing else. So, has this thing beaten me?
The thing that mauls and mutilates our race. Not killing us outright, but letting us live on with half a heart and half a lung.
Have I finally been beaten on this channel by an amplifier? I think I may have been just beaten by an amplifier, because I'm at my wit's end on this. Let me think on this for a bit, and I'll come back to it. Okay, I think for a second, I'm going to stop looking at this thing schematically, and we'll start just looking at it physically. Now, the one thing that I can see, the only thing I really left, and holy shit, if this isn't it, I won't even know what to do. I think I'm actually going to be scared to sleep. As a matter of fact, you know what? I think I'm already asleep, and this is a nightmare for real, and I have died or something, or I'm in purgatory, and all you guys are just my own creation and my illusion inside of my head, and this amplifier literally is the devil. I'm hardly even joking at this point. It's just God. Okay, so here's the only thing I can see, physically speaking, that is left that could possibly be doing this. Because I did replace these screen resistors, okay? These are 2-watt screen resistors of the same value. I replaced all 4 of them just for consistency. But these were the 2 that were on the side in question. Okay, so if we imagine for a second that something is happening on this side over here to cause a leak of voltage to ground or to another trace or something from one of these points, and if it's only happening when the circuit gets hot, that could potentially cause this problem. And frankly, it's all that's left. It's all that's left. The output transformer is out. Anything previous to these coupling caps is completely out. Alright? The 2 330K resistors in the bias circuit are out. Especially the one in question, which is the only one we're even concerned with. That one is out. Okay? The only thing it could be, I guess, maybe the connection on this side, the pad or something that's wrong. But the thing is, this one gets its connection through that pad. So that doesn't make any sense. I don't even know if you guys know what the fuck I'm talking about. And I've actually stopped worrying about the presentation of this video. This is how bad this is. The only thing left I can figure at all is going to be something to do with these screens. I did go back and refloat all the solder over here on these just to make sure it wasn't something I did putting it together, and it's not, clearly. So what the fuck, man? Seriously, what in the fuck could it be besides this? If it's not this, I'm serious. I think I'm gonna conclude that I have died for real, and I'm in some kind of purgatory. I'm in some kind of hell. And this is just my way of my it's like Jacob's ladder or something, you know.
The only thing that burns in hell is the part of you that won't let go of your life. Your memories, your attachments. They burn them all away. But they're not punishing you, he said. They're freeing your soul. Relax.
And this amp is like, represents my ego and not wanting to be beaten at something, you know? And all of you guys are just manifestations of my greater ego, my need to feel needed. This is the psychotic place to which I've been driven. Okay, so there has to be a place where the 300 volts that feed the screens kind of splits off and goes to one side and then to the other. There is going to be a place where that splits off. I can't see that really from where I am right now. It looks like it might be on the other side of the board, that trace. I believe it is. I believe that trace comes in on the other side of the board. Does that mean I'm going to have to pull this fucking board again? That would be perfect. But yeah, definitely one thing I could do, I could try to find the source of that 300 volts. Looks like that same 300 volts also feeds the reverb transformer. Alright, so it looks like the supply that feeds the screens comes off of this 30 microfarad capacitor right there. So that lead, and we'll trace that out. So yeah, it goes to right there, and then under all of these, up over to here, and somewhere over in here under the board, it'll split off and then feed this side, right? Yeah, those two. So somewhere over here it splits off and feeds both of those, and there should be a trace underneath that feeds them. But this side is fine, so the problem would be somewhere over here, if this were the case. But why wouldn't it affect the other ones too? That doesn't make any sense, does it? Doesn't make a lot of sense. I think what I want to do though, I suppose it's possible, like if this point right here, like this pad for instance, if it was leaking to ground, what would happen is you would start to lose everything. You would lose screen voltage, and everything else would kind of follow. And you would expect one of these to get hot though too, wouldn't you? And also further down the line, if you follow this on out, it comes around and around and goes to here. There's one resistor right here that feeds one of the plates of the phase inverter. There's another one here that feeds the other plate of the phase inverter. At one point I did check the phase inverter voltage on the plates, and the voltages at the same time the voltage was diving on this side. The voltage also takes a dive on the phase inverter plates at the same time. All of it's being dragged down. My working theory right now is that somewhere between here and here, so that one and this area, on that trace, something is being bled to ground, is causing these voltages to crash on the these tubes on the screens initially, but it's dragging everything else with it. And then here on the phase inverter also, it's the plates are taking a dive. But if it does turn out to be that this is the issue, he could play 3 gigs with this, and then another part of the board might start being conductive. Okay, so I've just tacked those together temporarily up out of the board, and I'm just going to take a gator clip. Actually, I'm just going to clip at this point, and I'm just going to simulate that trace from there over to directly off of this. Yeah, here's what I expect to happen. I expect the bias voltage to stay steady at this point on this side, but I expect the voltage on the plates for the phase inverter to continue to dive off, and it would still fail if left alone, because it would just lose all plate voltage on the bias on the phase inverter. 298 volts on pin 1, and we'll do pin 6, 2, 3, 4, 5, right here. 285 on that side. So 291, or excuse me, 298 and 285. Looks like we might still be creeping down. 296, so we've lost a couple volts there. That one was 282, so we've lost 3 volts there. Okay, on pin, what do we got? V5A. Should be pin 1. I can't even see that one. There's so much shit in the way. Can't even see that pin. Is that it right there? 340 volts right there. I think that is that what I should see? I'm supposed to see about 300 volts, but I see 340. But it's still in the ballpark though. Plus the reverb is I don't know. Don't know on that. 293, 78. So yeah, we've lost what? 5, 6, 7 volts there. Creeping downward. 13.7. See, it's creeping. It's running away. It's still running away. This one's still steady at 14.6. Well, I say it's steady, but maybe it's creeping down also, but just slower. You know? This one's certainly creeping down, without a doubt. Still. $338 on the screen supply, and it's coming directly off over here. 332, 331, 330. Yeah, look. Look at this. Look at the screen voltage supply, and it's happening. See that? See that? It's losing screen voltage. It's just losing it entirely. It's also losing it on the other side, but just not. It's not showing up. It's not showing up as a loss of bias voltage like it is on this other side. So that's interesting. That's actually very interesting. Okay, so in the power supply, we have 3 different nodes. We have a node that's coming off of the 2 biggest capacitors over here, and that feeds the plates of the output tubes. So that's our A node that comes off of these. We have a B node that comes off of this one right here, and we have also a C node that comes off of this one, and it's further downstream than this one is in terms of the power supply. So I want to see if I'm losing voltage on C node as well as B node. What I'm thinking is if this board's heating up and we're having a failure on one of these pads and we're getting and the voltage is just kind of getting cut off, so it's starving everything downstream. I know we're losing voltage here, right here at this point. Actually, voltage is being lost right here. So I want to look further downstream. I want to see if voltage is also being lost here. Okay, this thing keeps just getting more and more frustrating. The symptoms seem to have changed at this point, and instead of only one side taking a dive, it seems like everything is taking a dive. But this side is going more slowly on the bias. Plate voltage, screen voltage, everything is diving. I've checked voltages at the various nodes. The A node is on that red wire right there. That's the center tap, so I can measure that right there. Here's the B node coming off of this one, and the C node is back there. All 3 of those nodes are taking a dive in terms of voltage, and by that I mean if we look at the schematic. Okay, here's the power supply right here, and you can see off the secondary of the power transformer coming into A node right here. So if I measure at this point, the voltage is diving off. If I measure at this point, it's diving off, and at this point, it's diving off. So it's the problem seems to be originating at least this far back in the power supply, because the voltage right here at this point is just taking a nosedive after a certain point, and it's doing it reliably every single time. So what I'm doing here is I'm going through. I'm going to systematically start replacing things in this power supply. probably beginning over here. And the first suspect is this capacitor right here, this 047. It says 600 volt, but it's actually 1000 volt in this example. And I've already changed that, or actually I didn't change it, I just lifted the leg to remove it. And all that's supposed to do, it's supposed to damper the standby switch when you go to standby, like if you have it really loud. It should just kind of damper that down a bit. But here's the thing, right now I have lifted that, so it's out of circuit. It's that one right there. And I'm checking my bias, and it's diving off. I'm down to 13.2, and it's just diving. I can check the A node, and this thing starts out about 430 volts right there at that point. But right now it's down to 422. And here in just a bit, it will start diving off. Well, I mean, it's diving continuously. You can see it going. Right now it's at 421. It'll go down to 420. You'll give it a couple seconds, and that'll dive down to 419. It just keeps creeping down overall. This side over here is going faster than anything, and I think maybe that's just because the tubes that are in here are maybe weaker. But at the same time, I've already swapped these tubes around, and it stayed with the socket. So that part I don't get. I don't really understand why it would be doing that. But that is one of the symptoms. Same thing on the B node over here. I can check the B node, and that voltage right there will just keep creeping downward, down. You can see it going right there. It's just steadily going down. It's actually racing down. Here's the C node, and we've got our wattage overall is creeping up. Here in just a second, the speaker's going to pop, and it's going to tell me. See, it's just the C node is diving down. You hear that? Look at that. This is the A node. It's just crashing. Voltage just crashing. So I know that it's not that capacitor right there. That's not it. It could potentially, I guess, be one of these resistors, the 220Ks. Those are bleeder resistors, and if they're if they're shorting, but see, that doesn't make a lot of sense, because you've got built-in redundancy here. So you've got two components that would have to go bad. You hear the same thing. You got two components that would have to go bad in basically the same way. It just doesn't make sense. The only thing at this point that makes any sense is that right there, that power transformer. I think the power transformer in this thing is bad at this point. It's either that or this board is becoming conductive. And here's the problem I'm faced with. If I go and order a power transformer at this point, just like I did, ordered the output transformer with good faith reasons to do so and to suspect that it was the problem. However, it's turned out not to be the problem. So I'm going to have to eat the cost of that transformer. I can't justify passing on that cost to the customer, so I'm going to eat that cost, and that's $50 down the drain. If I go through here and shotgun all the capacitors, and they're not getting hot either. I can look at those under the thermal camera, and you would expect those to get hot if they are dragging everything to ground, and none of them are getting hot. They're not showing up any hotter than anything else around them. So they're not the culprit in this. But the thing is, if I order that power transformer right there, I'm going to end up in a situation where if that power transformer, if I replace it and that doesn't fix it, then I'm going to have to eat the cost of a power transformer also. Because there's no way to install it without clipping all the leads to the correct length and all that stuff. And you can't return it after that. So what the fuck am I supposed to do with this? Do I order the power transformer under good faith once again that it's going to solve the problem? And then if it comes back being a conductive board somewhere, then I'm truly screwed. I can lift this all day long, but if it's the board surrounding it that's going conductive or something stupid like that, which I really don't have any faith that's not happening, then I'm sure you can see what I mean here. I'm kind of caught between a rock and a hard place on this fucking thing, and to be honest, I just want it off my bench at this point. If I were to, if my other option is to see what this customer wants for what remains of it, because to replace this the power transformer is probably going to cost quite a lot. I'm going to have to pull this fucking board for a 4th time on this project, and every time I pull this board, that takes the cost of this repair further and further upward. Now at this point, I'm eating most of this. I'm eating most of this repair, and that's a major problem for me because it's costing me money at this point, and it's just I need this thing gone. And it's no offense to the dude that brought me this. It's not his fault. He doesn't know. He just wants his amp fixed. But the thing is, you know, this all began because Mesa-Boogie doesn't know how to design an output without basically biasing the thing twice what it needs to be biased at. But we've got a massive problem somewhere, and I'm not comfortable saying which of these is the problem, whether it's the board being conductive somewhere or whether it's the power transformer. But it's going to cost quite a bit to find out, and I don't know if this guy wants to pay that kind of money to find out or not. I have to decide what I want to quote him on going forward, and I may even just make him an offer to buy him out of this thing and just strip what components I can off of it that I can maybe use. You know, I mean, just things like the pots, the chassis possibly. And I think if I do buy this thing, I'm just going to take it out in my driveway or out in the street, and I'm just going to stomp the fuck out of it, because that's where I'm at right now. So we might get a show out of it. I'm going to call him, actually, talk to him about what's going on, level with him on what it's probably going to cost to go forward, and see what he wants to do. Okay, so I just got off the phone with the owner of this amplifier, nice fella named Brian, and we had a long conversation about it. And I've told him where I am on this thing and where it has come. Again, I've spoken to my friend who's a Mesa-Boogie authorized service tech, and you know, we both concur that I've pretty much done everything that he would have done. The only other things that it could possibly be, it's kind of down to either the power transformer on this thing or the board on this thing becoming conductive somewhere. And there's just nothing obvious on this board that would tell me where it's becoming conductive. And the problem is I can't pull these tubes out and make it happen. The tubes have to be in it, so I would have to burn up a pair of tubes to even find the spot on the board if it is arcing on the board. If I just wanted to let it go and let it burn up or something and just see where it smoked, you know, I would have to sacrifice at least one pair of tubes, if not all 4 of them, on the output. There's also no telling what else I might sacrifice. Furthermore, the transformer is going to be probably up around the $200 range to get the transformer with shipping and everything. Plus, I'm going to have to pull this board out of here for the 4th time on this repair, okay? Which is going to run up the repair bill further again. With what this guy already had in it, with what he was already looking at for my building out of this, I was actually going to eat the output transformer because it's my fault that I didn't test it more thoroughly. I trusted the test that you know, that I was given to make, and that test, again, that's a valid test. That came from PremierGuitar.com. That's not something I just fucking made up. So anyway, it failed that test, and I bought the transformer on the assumption that the test should have been valid, and it turns out it was not. So I was just going to eat the transformer, the cost of that, which was going to be $50. But anyway, long story short, talked to the owner of this amplifier, and we're going to trade. He's trading me what remains of this, the parts of this amplifier, the hunk of junk you see in front of you, the satanic piece of shit that you see in front of you is now mine, and instead I'm going to owe him some labor on another one of his amplifiers, which which is fine by me because the other amplifier he's going to bring me is a vintage Ampeg amp, which is point-to-point wired rather than this horse shit. So here's what's going to happen. I'm either going to have a really good time destroying this thing, which is extremely tempting, or I might strip it of parts, or I might do a little bit of both. I might strip it of the parts that I can use, and then we might take it out into my driveway and just destroy the fuck out of it, because I'm fed up with it. I might even paste an effigy of like Randall Smith's head on the thing as I destroy it or something like that. But I'm telling you, man, this has been the worst kind of experience. This has really put me off of Mesa amplifiers. You know, as nice as they've always kind of been to me on the phone, it really doesn't make up for what I've had to go through on this thing. And this is kind of the place that you get stuck in sometimes as a repair tech. And nobody is going to put this stuff up on YouTube for fear of all the fucking trolls coming after them saying, oh, you're a parts changer and all this bullshit. And you know what? To the people who call me a parts changer, fuck you. You don't know what you're talking about. You don't live in the real world. You're watching too many goddamn YouTube videos of people who scrubify everything that they do. And make it all sanitary and make it seem like they're goddamn geniuses. The real world, you test something. You test a theory, you pull a leg up, you replace a component to see if your theory is valid. And if not, you leave the fucking 10-cent component in. You know, what is it? It's 10 cents. So what? You know, you develop a theory, you replace a couple of things, then you retest to see if it fixed the problem. And to call somebody a parts changer for that, just kiss my ass, seriously. If you don't like this channel, then go on. You can find or you can find about 10,000 other tech channels that will just basically scrub all of the mistakes so that you think they're goddamn geniuses, okay? Go watch those channels instead, because you don't belong here. But anyway, with that off of my shoulders, I feel much better because this amp is now my hunk of junk and I can do with it what I want. Like I said, I think I'm going to strip it of some parts, and then beyond that, we'll see what we want to do.
For hate's sake, I spit my last breath at thee! Thou damned whale!